Hey students, how you doing? This is Mr. Elliott here. I'm your math teacher this year, and I'm really excited because I'm about to do my very first video lesson of the year. Let's hope it goes really well. Here we go. The topic for this very first video lesson is called linear relationships. Now, do you need to take notes on this? You should. Note-taking, it's a valuable skill, and where these video lessons within my class, you'll be able to pause it and go as fast or slow through this lesson as you want to. In a normal classroom, you don't have that option. So practicing taking these notes on a day-to-day basis is a valuable learning tool. So pull up some paper, pencil, take some notes on this, get better at note-taking. I'm also will keep a link that has a copy of these notes. So if you really are a really bad note taker, you can always print up these pieces of paper beforehand and then write your own notes in my notes. Maybe that'll help. So the topic of today's this first lesson is linear relationships. And my first example I have for you is right here. We are given a linear equation. And that linear equation is 6x plus 3y equals 5. And in part A, what they'd like us to do is find y when x is equal to 2. Okay, well, first thing you want to do, they tell you right here that x is equal to 2. So we want to take our equation and we want to rewrite it. It's always good to rewrite the entire equation first. And then everywhere we're going to go through this equation, and everywhere we see this x here, we're going to plug in a 2. And of course, when a 6 and an x are right next to each other, that means multiply. So I have 6 times 2 plus 3y equals 5. And what is 6 times 2, class? It's 12, Mr. Elliott. So we change 6 times 2 to 12 plus 3y equals 5. And then what do the instructions say? The instructions mention here that we need to solve it for y. So we're going to take this equation, algebraically solve it for y. Don't forget that whatever you do to the left side, you have to do to the right. And that first step, I want to move this 12 to the left side, so I subtract 12 from both sides. That leaves me with a 3y on the left side. And on the right side, 5 minus 12 is negative 7. And then to finish getting y by itself, we would divide both sides by 3, because it currently says 3 times y. So if you want to get y by itself, opposite of multiplying, divide. Divide by that 3. Over here, on the left side, those 3's cancel out. Y is now by itself. And on the right side, 7 and 3 do not divide evenly. So we leave our answer as y equals negative 7/3. All right. Part B. In Part B, they tell us to still use this given equation, but we're going to solve the given equation for x. So we're not going to plug in any values. We're just going to solve the equation straight away for x. So just as a reminder, it's always good to write the equation out before you start a problem. I have 6x plus 3y equals 5. And if I'm trying to get x by itself, I first need to move this 3y, because the 3y is being held by addition. And whenever you're doing algebra, you always do the opposite of the order of operations. So at the end of our order of operations is adding and subtracting. So that's the first thing we do with algebra. So I subtract this 3y from both sides. On the left side of the equation, 3y minus 3y cancels out, so we're left with the 6x all by itself. On the other side, 5 is a number, 3y is a variable, so you cannot combine them. They need to remain separate. You could write 5 minus 3y. You could write negative 3y plus 5. Either one. I always like writing the variable before the number, so I'm going to write negative 3y plus 5. Last step, to get x by itself, we divide both sides by 6. And now at this point, there's a couple different ways you can answer this problem. You could answer it just as it reads right now. Negative 3y plus 5 all divided by 6. That is a completely acceptable answer. But at the same time, I noticed that 3 over 6, I can simplify. Simplifiable fraction. Negative 3 divided by 6, that's equal to negative 1/2. That would make this negative 1/2 y. But if we divided this negative 3y by 6, we also have to divide the 5 by 6. But 5 and 6, those don't simplify. Those don't divide evenly. They won't do anything. So I just leave it as 5 over 6. So at the end of the day, solve for x. This is an acceptable answer. X equals negative 3y plus 5 all over 6. And another acceptable answer is x equals negative 1/2 y plus 5 over 6. So either answer, good to go. All right, there is a part C to this problem. We're using the exact same given, but in part C, it says to find the x-intercept. Now, the x-intercept is a coordinate. The x-intercept is a coordinate on our x-axis, and what's common about every point on the x-axis is that the y-coordinate is always 0. So we know that the x-intercept will occur with this equation when the y-coordinate is equal to 0. So I go 6x plus 3 times 0 equals 5. Well, let's see. 3 times 0 is 0. So that just gives me 6x equals 5. And if I finish solving this equation for x, divide both sides by 6, x equals 5 over 6. Now, this is not my answer. Like I said at the start of this problem, the x-intercept needs to be a coordinate. So the x-coordinate is 5 over 6, the y-coordinate is 0, and you have your x-intercept. Now I'm going to move right into part D, and then I'm going to connect part C and D together. Part D is to find the y-intercept. Now, if the x-intercept is when the y value is 0 on the x-axis, the y-intercept would be a point on the y-axis, and every point on the y-axis has a 0 for x, and then some y-coordinate. So I'm going to plug in 0 for x in this case. So using this exact same equation as before, 6 times 0 plus 3y equals 5. 6 times 0 is 0, so this simply goes away. I'm left with 3y equals 5 to finish solving for y. Divide both sides by 3, and y ends up equaling 5/3. Just like the previous problem, the y-intercept isn't just 5/3, it needs to be a physical coordinate, so it's 0, 5/3. What's nice about finding x-intercepts and y-intercepts of a graph or of an equation is that if you had to do a quick graph, knowing exactly what the x-intercepts and y-intercepts are allows you to quickly draw that graph. 0, 5/3, you could label it as being 0, 5/3. 5 over 6, 0. You could label that point as being 5, 6, 0. And because you know this is a linear equation, the graph for this particular equation would be the line that passes through the x and the y-intercept. So that's how you can quickly use an x and a y-intercept to draw a linear graph. It's a helpful technique. It works. Okay. That was all of example 1. There are a couple more homework problems that I thought would be worth talking about. Let me get that going for you. Example 2 zoom back in here. So on that one, I'm given this, it's a linear equation, but it involves a fraction. It's kind of complicated. X minus 6 over X plus 5 equals 9 over 2. And the instructions are to solve for Y. Well, what people don't like about problems like this is the fraction. I understand fractions are a pain in the butt. So there's a couple different ways you can handle this. First technique is the way that my brain immediately sees this. It's a two-step problem. If you're trying to solve for y, which is in the numerator, you could quickly eliminate this fraction on the left by multiplying both sides by the denominator x plus 5. So I'm going to multiply the left side by x plus 5. I'm going to multiply the right side by x plus 5. On the left side, x plus 5 divided by x plus 5 is just 1, so those cancel out. Very nice. And what you're left with on the left is simply y minus 6. On the right, you still have the 9 over 2, and now you also have the times x plus 5 that we had before. Then finish getting y by itself, because that is what the instructions mention right here. To finish solving for y, we would simply add 6 to both sides. And you end up with y equals, well, this is all being held together by multiplication, and you have a variable here, so it doesn't really mix with this plus 6. So we just have 9 over 2 times x plus 5, and then after the parentheses you'd have your plus 6, and we've successfully solved for y. Now, that's how I'd go about solving this equation at this stage of my life. When I was in high school, and I saw a fraction equals fraction problem, I used cross multiplying. So y minus 6 over x plus 5 equals 9 over 2. And it was always like this, that you could cross multiply and go 2 times y minus 6 equals 9 times x plus 5. All right. Well, if I wanted to keep going with this, I'm trying to get this y by itself. So I could divide both sides by 2 right now. That would eliminate those parentheses. 2 divided by 2 is 1. Those cancel out, and I'm left with y minus 6. Over on this side, 9 divided by 2 does not divide evenly. So I just have 9 over 2 times x plus 5. And if you've noticed, we did cross multiplying, we divide by 2, and now we're pretty much in the exact same spot that we were here. So you could just simply add 6 to both sides, and you'd have y equals 9 over 2 times x plus 5 plus 6. Oops. All right, so students, that is 2 separate ways to solve the exact same equation. Both of these techniques work, and if you have a third technique that you like to use that allows you to get the same correct answer, use it. All math is good. One more example. Example 3. And then this one, it's a similar type algebra problem. Let's say I'm given y equals 8 plus 3 times x minus 2, and the instructions are to solve for x. All right, well, x is way here inside those parentheses. So step by step, I kind of need to move over the 8, then I need to move over the 3, then I'm going to need to move over the 2. That 8's being held together on by addition, so that's why we're going to move it first, because you always do with your addition subtraction first. Subtract 8 from both sides. On the left side, that leaves me with y minus 8. On the right side, that leaves me with 3 times x minus 2. Second step, I notice that I have 3 times the stuff. So if I divide both sides by 3, these 3's cancel out. On my right side, I'm left with x minus 2. on my right side, y minus 8 over 3. And I would leave this just like this because y does not divide evenly with 3. 8 does not divide evenly with 3, so there's really no reason to divide this 3 out. My last step, I would want to add 2 to both sides, and I end up with x equals y minus 8 over 3 plus 2. Not the prettiest looking answer, but we have solved this equation for x. Okay, students, the purpose of this lesson was to help you out with your homework problems for Wednesday night. And your homework problems tonight are page 123, numbers 1 through 3. You'll notice that on page 122 there are some notes. Those notes will hopefully, they could be helpful to you, so give them a read over. And try out these 3 problems, and if you're able to do these 3 problems, you're in a good spot. Don't forget to check those answers, and when we come into class tomorrow morning, on Thursday, the first thing we're going to do is we're going to take questions on these problems. So, have yourself a great day, and I will talk to you on Thursday. Bye-bye. Oh, wait, make it big. Make Elliot big. Whoop. Then say goodbye. Goodbye.